Yes, class. So yesterday we had completed this portion of nuclei. Uh, Completely we didn't complete it. Let's do the rest of the portion. So initially we had seen the basics of it, concept of proton, neutrons and all. And then I told you that what about the nucleus size? So I told you that radius of a nucleus is directly proportional to the mass number. So that becomes 1/3 of it. So R is equal to R naught, A to the power 1/3. Now, nuclear density, when we are talking about nuclear density, density is equal to mass of the nucleus by volume of the nucleus. Simple formula of density. Density is equal to mass by volume. Now, density, when we're talking about the mass of nucleus, see, average mass, I have taken it as M. Average value of mass of a nucleon, average value of mass of nucleon, this is taken as M. And each, when we're talking about the each separate mass number, that is A. So total mass of the nucleus will be M into A. Volume will be 4/3 pi R cube, right? This will be pi R cube. Now see, R we can replace it as MA by 4/3 pi R naught A R naught cube. And this 1/3, when we'll cube it, it will become A, right? See, this was R naught A to the power 1/3. When you will cube it, this will become R cube and this is A only. So A will be cancelled. This is equal to 3M by 4 pi R naught cube. Now see, this is independent of the mass number because A got cancelled. So density, 3 is fixed, right? When we're talking about the average mass of a nucleon, we know the mass of a proton, we know the mass of a neutron. So this is also fixed. 4 we also know. Pi is a constant. And R naught also yesterday I told you that is 1.2 per meter. So density is equal to 3. This will be 1.67 into 10 to the power minus 37. This is the value that usually is taken for the mass of a nucleon by 4 pi. So 4 into 3.14, then cube of it. So that becomes 1.2 into 10 to the power minus 15 whole cube. So density is equal to 2.3 into 10 to the power 17 kg per meter cube. This is the density. So you take any element, iron, you take any element, cobalt, you take calcium, you take magnesium for every element, because since this is not depending upon the mass number, density will be 2.3 into 10 to the power 17. So whichever element is given to you, this will be constant. So this is universally constant. This value will be fixed. Let's see some questions also. Write this down first. See, this says that calculate radius of germanium. Okay, see, here it's mentioned 1.1 fermimeter. So you will take R naught as 1.1. If it's not mentioned, take it as 1.2 fermimeters. Now R is equal to R naught A to the power 1 by 3. So R is equal to R naught is 1.1 into 10 to the power minus 15. Or let's write it in terms of fermimeters only. A is 70. So this becomes 70 to the power 1 by 3. So this will be, see, 4's cube is 64 around something. So this is around 4.12. So when you will solve this, radius will be 4.53 per meter. Easy, like this questions only you have from the radii part. Okay, this question I'm discussing, this we haven't discussed. There's an Einstein equation, E is equal to mc square. This was a major part of your radioactivity, but this will come here when we do mass defect also. E is equal to mc square. C is the speed of light, m is the mass. So if mass is given and energy is asked, we write it in this term only. Once this question came into NEET also. 10 to the power minus 3, c square. 3 into 10 to the power 8 meter per second square. So this should come around 144 into 10 to the power 13 joules or 12 joules. Just check the answer. Write it down. 2 more questions I'll discuss with you. It says that assuming protons and neutrons have equal masses, calculate how many times nuclear matter is denser than water. See, density of nucleus, I told you this value is fixed 2.3 into 10 to the power 12 kg per meter cube. This value is fixed. When we are talking about density of water, that also we know it is 1000 kg per meter cube. So basically we have to find this ratio only. Nucleus by density of water is equal to 2.3 into 10 to the power 12. This is 17, sorry, not 12. This will be 17. Nuclear, 17. By 1000. That is 2.3 into 10 to the power 40. This is the ratio. This question all of you will answer in the chat column. Last one. Yes, class, answer. Fourth question. Amna, Austin, Deborah. There's also Shahid. Answer. Amna and Sidra have answered correctly. Yes, Austin. Right. You didn't have to calculate anything in this question. See, nuclear density, I told you it's fixed. Nuclear density is fixed. Whichever element is given, straight away write the answer as 2.3 into 10 to the power 17 kg per meter cube. Here also we did the same thing. Understood? Do not waste your time in calculating the questions of nuclei of this, specifically this. Quickly write it down, those who haven't written. Then we'll start with mass defect. That's the last topic of nuclei. Okay, now coming to mass defect, when we talk about the total number of protons, see, total number of protons is Z and mass of a single proton is MP. So total mass of protons will be ZMP. Similarly, total number of neutrons, this is A minus Z, and mass of a single neutron is Mn. So total mass of neutrons is A minus Z into Mn. And total mass of the nucleus, we are assuming it to be Mn. Now, when we are starting with the mass defect, delta M, this is ZMP. That is total mass you will add. Total mass of these you will add. These you will add ZMP plus A minus Z Mn. Then you will subtract the mass of the nucleus. All these information will be given to you in the question. This is basically the mass defect. Mass defect is seen when atoms are fusing or fusion of atoms, this is occurring, or the atoms are splitting. Suppose in respective components, atoms are getting split up. So some of there can be initially before the phenomena that occurred, if you look at the mass, and after the splitting, if you check the mass, there will be certain slight, very slight defect. That is, some mass has been wasted. That is known as the mass. So we have a concept known as binding energy. Binding energy means this energy which is generated in this process when it is splitting. So we call this as binding energy. This is equal to same thing, see, delta M into C square. So actual formula of binding energy, this will become, this is this, it's written over here. The formula of binding energy will become, this is entire mass defect into C square. And one more formula you have, binding energy per nucleon. Binding energy per nucleon. Nucleon means, so you will take the mass number. So binding energy is ZMP plus A minus Z Mn minus Mn into C square divided by A. Here A is the, here A is the mass number. So these are the formula that you have to remember. See, one more thing you can do. Just calculate, instead of multiplying it to the C square and all, calculate the mass defect multiplied by 931 mega electron volts. So you will directly get your answer in mega electron volts. So no need to write C, speed of light, then square it and then multiply it. Write it down. We'll practice a numerical, so this will become clear. Calculate the binding energy per nucleon. Calcium, 40 nucleus is given. Mass of calcium is given. Mass of neutron is given. Mass of proton is given. Now, see, when we'll calculate ZMP. Z is 20 for calcium. MP is given as 1.007825. A minus Z, Mn. That is 40 minus, again, this will also be 20. 1.008665 is equal to 20.1733. So this will be equal to 20.156. So when we'll add these, that is ZMP plus A minus ZMN, that is 20.1565 plus 20.1733. This is equal to 40.3298. Mass of calcium is given as 39.962589. And the element that we have calculated is 40. So when you will subtract these two, this will be 0.367. So this is the mass defect, 0.367. This is the mass defect. So binding energy per nucleon when we'll calculate, this will be 0.367 into 931. And since this is A is 40. So this will be approximately 8.541925. Something like this. It is its answer. All this you have to do without the calculator in your exams. So the decimal values, you cannot round it off here. That if you're getting 20.176 or 40 point something, let's take it as 40.2 only, 40.3. No, you have to take all the decimal places, whatever decimal places are given. Write it down. Okay, and now that completes with nuclei. Now starting with dual nature of matter and radiation. So see, in your notes, everything is mentioned. Some terms are there. See, if this is a, let's say a wire segment, a conductor is present. So in those electrons are present. These electrons are present on the surface of metal. Let's say this is some metallic element. Now every electron has a minimum value of wavelength, has a minimum value of frequency, has a minimum value of potential, and has a minimum value of energy. These have to be fulfilled, and when all these values are fulfilled, the electrons eject from the metal. Now this can occur through different processes. If this is occurring through the sunlight, we call it as photoelectric effect. Different types of um, ejection of electrons through different mechanisms are possible, that we'll discuss later. But first see these. So when this is the wavelength. So certain wavelength is required for the ejection of electron to occur. This is known as the threshold wavelength. This is known as the threshold wavelength. Secondly, you have the certain frequency which has to be crossed. This is the minimum. All these are the minimum values. These minimum values have to be kept. So frequency, this is known as the threshold frequency. This is the threshold potential. We call it as cutoff potential. We'll discuss this later. And this is very important. That is the minimum energy which is required. This is known as the work function. So all the electrons are present. Every electron will be having all these criteria. And once this is fulfilled, the electrons go out. So let's see the definition. See, work function is what? Work function is the minimum amount of energy required by an electron to just escape from the metal surface. This is called as the work function. 1 electron volt, you should remember for conversion, 1.6 into 10 to the power minus 19 joules. This will be used. All right. So this is 1 electron volt is 1.6 into 10 to the power minus 19 joules. Now, different phenomena I told you through which electrons can come out. One is known as thermionic emission. Thermionic emission means because of the thermal energy, the electrons are coming out. Sufficient thermal energy, heat is provided, and that is letting the electrons move out. Okay. Next is field energy. This is a process. Field energy means cold cathode ray tube is connected, and that emits heat, which leads to ejection of electron. Then you have secondary emission. Secondary emission means moving electron. That is, if this electron is already here and this electron moving from here comes here and it pushes it off. So this can go out. This is known as secondary emission because of the collision or moving electrons. Then you have the photoelectric emission. If the same thing is occurring, but these rays are light rays from the sun, then we say this is photoelectric emission. Electrons are coming out. These are photoelectric emissions. All right, thermionic, field energy, secondary emission, photoelectric emission, all these. So coming to the details of photoelectric effect. So when light of suitable frequency strikes, not only frequency, I told you, frequency, wavelength, work function, and potential. So when light of suitable frequency strikes a metal surface, electrons are emitted from it, and this phenomena is known as photoelectric effect. Since this involves light, that is the sunlight. photoelectrons. Here electrons are getting emitted. So sunlight is in turn getting the electrons get ejected from the metal surface. Photoelectric effect. So when light of suitable frequency strikes a metal surface, electrons are emitted from this. This phenomena is called as the photoelectric effect. So an experiment was also conducted. Cathode ray tubes experiment was conducted. Here, this was an outlet. Here a vacuum pump pipe was taken. Cathodes and anodes, these plates were connected. Now this was connected with an ammeter, that is the which has the unit of mu ampere. This has the unit of mu ampere, that is in micro, 10 to the power minus 6. Connected to a voltmeter. This is connected to a rheostat. This is connected to battery. It's connected to key. This is the voltmeter and this is the ammeter. From here, the light ray enters. Electrons are ejected and move towards the anodic plate. From here, the amount of current is measured. From here, the amount of voltage is measured. And if you want to modulate this, you can use the rheostat to modulate the amount of current that is coming, which will be providing the necessary resistance. Now, photoelectric intensity, photoelectric effect, this was observed with some more elements. Like when we talk about the intensity, so it was observed in the same experiment. All these graphs are based upon this experiment only, cathode ray tube experiment. So if the number of photoelectrons were increased, if the photoelectrons, the number increased, so that means you are increasing its intensity. So basically what is happening? Number of electrons are increasing when you are increasing the intensity. So if number of electrons are increasing, it means photoelectric effect will increase, because more number of electrons will come, that will lead to more amount of current. So photoelectric current is directly proportional to the intensity. All right, this is the photoelectric current directly proportional to intensity. Next, this was the potential I was talking about. That was the effect of potential which I was mentioning. Stopping potential or the cutoff potential. So the value of the retarding potential, this is known as the stopping potential or cutoff potential, which is it's like the minimum voltage that is required for an electron to be ejected. So value of retarding potential at which photoelectric current becomes zero is the stopping potential for a given frequency of incident ray. All right. Now see, what is meant by this? Look at the graph first. See, it was observed that when photoelectric current and voltage were plotted against each other, these observations were made. These were done through experimentally. It was observed, let's say the first one, intensity came, frequency was fixed in this. Remember, frequency is fixed. So it was observed that the current increases and reaches a certain intensity. And when you increase it further, the potential's value on the graph when it is plotted is minus V0, let's say. Then again, the intensity was increased. Then it reached it was increasing slightly, then it reached a value. Again, it reached a value. Then when it was observed, the potential's value was observed through the voltmeter. It was observed that this was the same potential, the negative potential that was observed in the first case. Again, intensity was increased further. This means I3 is greater than I2 is greater than I1. This was the order. So I3 was greater than I2 was greater than I1, like this. So now what is happening? Again, you will see a value of current. This value of current that you are seeing, this is known as the saturation current. This is known as the saturation current. Means whatever you increase, ultimately a plateau will be reached. This plateau that is reached is known as the saturation current. And when you will see a potential's value in the voltmeter, it will be the same minus V naught, that is the stopping potential. So the value of retarding potential at which photoelectric current becomes zero is called the stopping potential for a given frequency of incident ray. All right, this is the stopping potential or the cutoff potential. This is the effect of potential. This I'll discuss it later when we'll see Einstein's theory. Now, effect of frequency. Suppose intensity is kept fixed. In the previous case, we had frequency kept fixed. Suppose intensity is kept fixed. So what is observed? If the intensity is kept fixed, it is noticed that in the previous case, when the intensities were different, saturation currents values were different for every element, right? For every intensity, saturation currents value is different. Here it is observed that the saturation value of current for all of them will be same and intensity frequencies will be different. And when you change the frequency, every current for that value of current, you will be having a stopping potential. Again, you'll have a stopping potential. So remember, when intensity is kept fixed, frequency changes, stopping potential changes. Okay? When the opposite occurs, that is frequency is kept fixed, intensity is variable, intensity is increasing gradually, stopping potential is the same and has different values of saturation current. Now this is the last case. Then tomorrow in the next weekend we'll complete. Threshold frequency, I told you, minimum value of frequency of incident radiation for which photoelectric effect occurs is called threshold frequency. Means this minimum value, suppose I tell you for an electron to be ejected, it has to have a value of 5 hertz. So unless you give it 5 hertz, it won't be able to cross it. If you're providing 3 hertz, if you're providing 2 hertz, 4 hertz, it won't be. As soon as you'll provide it the frequency 5 hertz or 6 hertz or 7 hertz or more, but that minimum critical value, that threshold has been crossed, then only it will be ejected. So this frequency, this is known as threshold, means the potential it can bear. PEE means photoelectric emission. Photoelectric emission. This is photoelectric emission. So this is threshold frequency. Now, when kinetic energy was observed, this is a very important graph class. These two graphs are very important, not only for your class 12, for your board exams, apart from your board exams also. These graphs are very frequently asked. Graph between kinetic energy versus frequency and kinetic energy versus intensity. Remember, kinetic energy, this is directly proportional. When we're talking about frequency, kinetic energy is directly proportional to frequency. You get a straight line. If I choose a point over here, I have a value of frequency. For that, there's a value of kinetic energy. If I'm choosing one more point, for that, kinetic energy has subsequently increased in the same ratio because both are directly proportional. But when we are talking about the kinetic energy versus intensity, so it is independent. You keep on increasing the intensity, highest to maximum value. Kinetic energy will not have any effect. It will be having one value fixed at that. These are some properties. We have specific laws also, but these graphs are very important, class. All these graphs are very important. Effect of potential, effect of frequency, these both the graphs of kinetic theory, all right, as well as this first graph. All these graphs are very important. Then you have these basic definitions are also asked in the exam, especially definition of work function and threshold frequency. These two are usually asked in the exam to write in your 1 marker or 2 marker questions along with rest of them. So be prepared for the definitions as well. In the class right now, you don't have to write anything because in the notes it's given. So please go through the notes which I've sent you. Any doubts if you have, let me know. On the next weekend, we'll complete this. Now see, from the next weekend, what we'll try, we have to complete wave optics. This will be completed anyways very quickly. wave optics has to be completed by next year, because some of you are having your maths classes also, and I've been informed that a lot of syllabus of maths is pending, so you need time for that as well. The students who are attending maths, they know this. So, and anyways, we have to complete our syllabus as well before the time. So wave optics is left. So most probably from 9 to 10:30, we'll have this class extension of wave optics. 1 hour gap you will have. JE students, Shahid and Fadil, I think you all have your classes. JE chemistry classes on Saturday, and I think Saturday or Sunday, one of the days you have. So there you will be having the class. After that, you can attend. This we'll discuss. You will be informed about the